and welcome to episode 4 in my C128 series. And this episode is going to be a bit different from what I originally planned. The last episode we saw into some diagnostics, and we also thought we finished the 128 DCR, but I actually left that on for several hours, and when I came back there was this green flickering on the screen, so that was a new fault we had to take care of. And I also started looking into the different diagnostic rooms that we couldn't get to work earlier. And in this episode I'm going to make some modification on a diagnostic cartridge to be able to plug something in the back. And I have also downloaded one other diagnostic that is not by Commodore, it's a third-part one that actually tests memory. And while this 128 DCR, it counts up money right, it works perfectly in 64K modus, but it still displays that it has errors in one or more bits on the high bank. So the memory test procedure on the 128 is, it's different from what you expect on a Commodore 64, because on a Commodore 64 this error would have been discovered. But that means that one of the memory chips on this DCR probably are faulty, and as you will see there are a lot of difference in what the different test softwares tells us are wrong, but every one of them agrees that not everything is as it should with this memory. And I have also not tested this now with the test harness. My old test harness is not compatible with everything on the 128, and there are some differences in the test harnesses between the different test ROM images for the cartridge for the 128 also. So this episode will be a slightly different episode, and we are continue work on our DCR. We are continuing to see into some of the internals of the 128. We are continuing to look into some of the workings of the cartridge port on the 128. So let's just dig in and see how far we get in this episode. Yes, the first ROM chip we are going to burn, or EEPROM, is a 32K EEPROM that is meant to fit in the U36 socket in the 128 motherboard. And we do have a Texas Instrument chip, and the voltage it seems about right, so I'm just loading the file up. And this file is one I downloaded from the internet, and this particular stuff I got from Jani's site, and this is the diagonally or something that is a rewritten memory test for the C128, and I'm just burning this into the PROM, and as usual I do an extra verify. I have it's of course the play on words here, but I have burnt myself with not doing a second verify on a EEPROM, and was set back for several weeks until I burned the same PROM again and got the result I deserved. I also had similar faults with the ROM chips when I did the MSX computer, and we can see now that the diagnostic actually is working. The BART's C128 diagnostic version 1. I do think there is another version of this too, but version 1 is at least what I have here. And we are going to perform the system RAM test on this. And as you can see, the test is running just fine until we get to the first bank. The bank 0 is the one used by the C64 and the normal startup of the C128. But the second bank, where you see that we got an error here, is the bank that is yeah, it's spare when you use your 128. It's actually possible to swap these two banks by swapping the CAS lines on the banks. But as we can see here, it's 4 bits that is marked as bad, and that means that we have 4464 chip that is bad. But is this the high byte or the high nibble or the low nibble? I'm not sure. But it seems to me like it is here that it is the least significant bits that are at fault. But again, there is no good way to know. But there is no reason to run this test again. We have tested this enough to know that this at least shows a fault. So let's just continue with testing the VDC RAM before we go and test one of the other rooms that we have available for the 128. And as you can see, the 64 kilobytes of VDC RAM works just fine on this computer, and since this is a 128 DCR, it always has 64K of video RAM, not the 16 that was on the original first revision 128. But here you can see the green flickering and stuff that does not look good for our 128 computer. I have explored and looked into my stack of projects, and I found this. From PCBWay you have to order 5 of each when you do order from this shared project stack of things. And I did order this way back to have this combined diagnostic and dead test cartridge for my C128 as a fun project. And one of the sides of this cartridge is actually marked here that this is an 8K cartridge with the normal address from 8000 to 9FFF. And that is what we had in our message board discussion about the 8K cartridge for the C128 too, when the room low was selected. And I've seen into this, or looked into this, and I found this simple schematic. I found several others with this simple schematic from World of Yanni, which is the same place I found the room ships. This actually is exactly the same design. Of course, there is not many variants of this, but I can use this in a really simple term. I don't have to do anything really, because I need to do one thing. I need to cut one single line and maybe drop it to 5 volt instead of ground. And that is, as you can see here, I need to take this purple wire here and just cut it, because this is the X-ROM line. So this need to be cut, because today it goes up here to a capacitor on the 5 volt line, and it goes here to ground. So this is connected to ground as it is. So I just break this line, and we really should be good to go to test this. This, by the way, is connected with this pin here to 5 volt, and that means that if I put in a cartridge with and also this one is connected to plus 5 volt, so that means if I put in a 128, 256 or 512K cartridge, only the upper part of the room will be selected. So any image I put into a room here that is bigger than the 2764 should be in the upper 8K window. I don't need to put mirrors of this everywhere, but because of these lines being put high, there will be the upper part that is selected. These will address lines here, that is the ones that is used on the bigger EPROMs. They will always be high. So I'm thinking now and taking a copy of the 588121 EPROM ROM image, and I'm going to burn it into a 2764 EPROM. And just see what happens. Of course, I have to take one of these PCBs here and just solder in a socket and this small capacitor. That's really all there is. And of course, I can also use the reset switch or the reset line. I might do that too. So that is what I'm going to do, and probably this will work with any 8K cartridge that should start from 8000. Yes, here's just to show you what modification I did on this cartridge, and it's really nothing. I did cut the PCB over here just to disconnect the earth connection from this point here and over to this trace down here. And I also took the capacitor. I do want to have a capacitor in there, and I just tied the earth pin to this line here that goes to this over here, that is the earth connection. So I just took this print over here. It's still connected up there. I only took the back side of this that is connected to earth or ground. It goes like so to this pin down here, and I just broke it over here. So that's the modification we did at this point on this cartridge. And of course, now we was ready to just burn an EEPROM with the 8K diagnostic software we wanted, and we do had 2 of those, I think. Yes, and this is an 8K ROM of the Commodore 585121 ROM image, and this is, as I understand it, one of the earlier ROMs for testing, and this looks quite a bit like the test harness ROM image that I'm using for my 64s, but this is stated that it's 128 and the DAS40. Maybe this means that this is 40 character mode and not 80 character mode. But as you can see here, this also indicates that there is a bad memory chip. But this test, yeah, it expects the original 128 with 2x8 memory chips. So it can't identify what is wrong, but does seem to fail on all 4 bits. So it indicates 4 memory chips. So maybe if I know which chip these are, I can identify what's wrong. Yeah, and here comes a slightly newer version of this ROM. It has a different, what should I say, file name or build number or something. It's the 789010 version of this. And according to the number, it seems like it's slightly newer. The layout and the fonts looks about the same. But it has some slight differences, of course. And I let this just run out and see what results will be in the end. Of course, I have no harness connected. Most of my things from my original C64 harness will work on these according to the text in the world of Yanni, and there also are some schematics for other test harnesses. There are some pieces, there is a difference, of course. The keyboard connector is different, and you have the serial port is different. There is 2 pins that are connected, but the user port, the cartridge port, of course, is tested by the cartridge, and the tape port, I do think every of them is the same. But of course, there also are at least 2 different harnesses for the C64, so there will be some differences. Yeah, and here it's like the newer versions of the C64 test ROMs, where you get the versions of the different ROM chips instead of them being bad if they are newer versions. That's good. And of course, except from the memory test, I do think that everything else here that shows bad is because of open harnesses, especially the 6526 things. And 6581, I don't know why that should say that is bad. It's the SID chip, but maybe it's because of the feedback from the potentiometers on the paddle ports on the joystick tester that we get this message here. The strange thing here is that this also expects us to have 8 memory chips in each bank, and here he just say that it's 3 bits that's bad, so it's not the same as before, but I let this run a couple of more times to see how this turns out. And now I've run this for I think 8 times and it doesn't give us any more messengers, so I'm just turning this off now. Yeah, as we saw earlier, me modifying this cartridge was a success. I was able to make the diagrams for the internal sockets. They was working as they should, and I was also able to make a 32K cartridge, not cartridge, ROM. And this was the diagram that was not made by Commodore, the RAM test. I was able to make them fit internally in the internal U36 socket. But I'm not totally there, because I do have some ROMs that we have downloaded. I don't know why I didn't find these at once, because Simmers is normally my go-to source for anything documented related when I'm doing fault finding on new Commodore systems. And here there are a lot of ROMs that have 16 kilobytes. And all these 16 kilobyte stuff here, and some of them are internal here. You can see here you also have these ROMs down here is 16K, and this one here is 16K. All these other are 8K here, and we do have this one here that is 32K, and also this one. And I also have to give a bit of warning, because I was using this burn-in test, and it does repeat an endless loop. And I had this going for maybe 2-3 hours, and then I come back, it was the flickery image on the 128 DCR that we had. So even though I put new cooling paste and stuff on the top of the video chip, I probably have damaged the 6566 R3 chip. But I will just try to replace that with another chip from either my spare board that has been hopelessly handled over the years, or I can just pick this from a working 128. So that's not a problem. But we need to have a way of installing these 16K EPROMs, and I can't get them to work internally in the sockets. I know there should be no reason why they don't work, but I've not been able to make them work. And if we take just and use this older cartridge that we modified as a guideline for what we need to do, we see that the only thing that is lacking for having a 64K cartridge be 128 is that you connect the address line 13. So 813 needs to be connected. We did have it connected to 5 volt here, and we just need to connect this to 813 here on the cartridge port. And we need to break the connection that you have down here between the not connected port on the old design. So that is what we are going to do. We are going to fit a wire to make this pin connected, and I'm going to use a knife to just cut these this trace here between these pins. And I need to be careful, so I do some taping over this area here to make sure that I don't get a lot of solder on this pin here. And this actually is the final result. You can kind of see the wire here, and this actually works, I hope. So let's continue and see how this goes on the 2728 from Pervida that we thought was fully working in the last episode, but as we now have at least 2 more faults that needs to be fixed. But at least we are learning a lot about the cartridge technology. And one more thing that actually is a thing, and it's the difference between how the 64 and the 128 handles cartridges. You know, on startup, a C64 cartridge, the normal way you have auto start cartridge is that you map it to address 8000, and you have this startup vector here where you have this as an address where you jump to, and you have the CBM80 characters embedded like so. And that's really everything that is to it for having an auto start cartridge on this C64. You just add the 2 bytes that you want of the final address to the 8000 bytes, the 2 bytes that will be here if you disassemble 8000, and you write the character CBM80 from 8004 and onwards. Then it will auto boot. And if you do have Ultimate cartridge, you need to put the start vector at the same place that the 6502 normally handles the startups. So this is all well and good, but there are some differences in the C128, and there are some things here I really don't, I can't really grasp all of this. And I've read through the pages 407 to 414 in the Programmer's Reference Guide. And the reason I did this is because I need to understand how the C128 really does the startup initializing sequence to be able to continue the fault finding on the board from Arctic Retro. And here they actually states it's about the same. They do have a CBM string. They do have some vectors that you can jump to here. They also included a cartridge ID here. That means that you can have several types of cartridges. This seems to work, but and there is also some priority between the internal socket and the external socket, and that is that if you put something in the internal socket, the external socket will have priority. And the external socket will of course be the cartridge port. And there are some confusion between you have an external that is high or low and an internal that's high or low. But of course you only have one socket. So this needs to be controlled by the address lines and the room high and room low signals. So there are a lot going on with cartridges, and more on 128 than it was on a C64. So we need to dig deeper into this, but that will not be this episode, as the episode already kind of got very long already. This is just a brief overview of the EPROMs and what you can see inside of the window. What you can see inside of the window is actually a glimpse into the die of the microarchitecture of the EPROM. And this is the same if it's not an UV erasable PROM, it's just that when you have the window, you will get electrons to pass through this through the light. And the die size more represent the technology used than the size of the EPROM, because the older EPROMs will always have a bigger die size than the newer ones, where each gate is packed closer together. And the bigger the gate size, the more voltage you need to program them. So some of the old ones that's using 28 to 29 volt programming voltage, they have really huge gates. But this is of course only smaller EPROMs with 8K and smaller. Here it's nothing. You might see better if I turn off this light. So you can see here the ripple on the 5 volt current. It's next to nothing. And if I isolate here and put it on AC, it's 157 millivolt. And now the machine is booted. So I'm not doing any drive access, but I do think the electronics here. But I can do the 12 volt. It will be this one. The DC component 11.7 volts. And I can also isolate the AC component on this, and auto. It's about the 7, it's swinging from 157 to 78 millivolt, and that's within what the accuracy of this meter is, so it's next to nothing. So the capacitors in the power supply, they are as good as they was when they was new, or they're not going to go bust anytime soon, at least. And now I've tested this machine with everything I got, and I did have a fault, as you saw, and this was the culprit. And the chip is the 8566 R3, and this is the VIC chip that is actually flickering. And I did take out the chip from this undiagnosed 128 board that I had laying around, and this gives a good picture again. So this is hopefully cured for now. It's always overexposed. Yeah, so that's it with measuring on this 128 here. Now I have to find another machine to hold this up against, and I'm going to use the 128 that I got done from the bunker that was working. So that's the machine I'm going to continue do the testing of the rooms on. So I just turn off this for the last time and put the lid back on so that the owner could get this back. Yeah, or wait a moment, we have to figure out this memory error thing that the other memory test has given us, so we got to run a couple of more memory tests on this board. And this is the test room that is specially marked with 128 DCR, and this does not look good. Is this locked up? We just have to wait and see. It's locked up. I've been waiting now for several minutes, so I just turned this off. It's clear that we do have a memory fault here, so we do have to take this into consideration and fix that as well. Yes, a bit of a warning. This is going to be all over the place because these diagnostic rooms, they are all over the place. And it can be excused because there are different models of the 128, of course. But this is really not a very good excuse, because if we start with the first one, this is the 588121, and this one is probably the oldest. I do think this is some kind of version number, and here it's of course stated that the high RAM bank 1 is bad. That's nice. We tend to agree on that on some level. And they say the kernel rooms are bad. And this is the same as the oldest version of the diagnostic harness for the C64. It doesn't recognize regional and altered kernels, and it doesn't recognize the newest version of the official kernel. And the same with the character room. And on the 785260 version, this is slightly better. It still agrees that bank 1 is bad. It gives us version numbers for these rooms, which is good, of course. And it also, it's about the same on the other stuff. But you can see here that this actually tells us that, first off, this is 4164K rooms, and this is 2462. I don't know what's up with that. And it also here stated that this is for the 128D, but the original 128D does have the exact same motherboard as the normal 128. So Why they have done that, I'm not sure. They state that these are the 3 ships that is bad, but here these are the ships that are bad. So they have somewhat changed the high and low kind of bytes around. I'm not sure if it's some error in the test, if they have swapped their own routines, or if this is just an error. It's very difficult for me to say. This stated the same as the first one, that is this the C128 in 40 column mode diagnostic, and it has an even newer version number. And here they state the same, this is bad, but here they state the same as in the first version, that these are the RAM ships that is bad. And that means the lowest nibble, if we look on the schematic which we have here, you can see that this is U46 to 49 and U46 to 49 down here. It's the lowest data from D0, and while this might be wrong, I'm not so sure about that. And we also had the fault where the VIC-2 ship was bad. And here you can see every memory test went bad. When I tried to test with this bad chip inside, you can see here every memory bank is bad. But if every memory bank has been bad and rotten to the bone, this test would not have been allowed to complete. And this is the test that actually is marked with the DCR, and they also called it the integral diag, and this one I have been able to make it run on the internal plug, but this is actually run by the cartridge, and this is also an early version, and I'm not sure what's up with that, but this page here I found on the oldest version of the diagnostic I got by, and they uses the same pattern here for diagnosing RAM. So you can see here that the RAM errors that it's listed as NG, not good, and the bank, the error address, error address, yes, and you have the write and the read data. So they have tried to write this and read out this one. And that we can see here, this is what they have been able to read, and this is what they have written. So the high part of the byte, the 4 uppermost nibbles, they are correct, but the bottom ones do have an error. And that means that these 2 here are stuck to 0. And we do also have here that this is bank 1 that is corrupt, so that is in accordance to this, and also it is in accordance to these ones here. And we also have the BART ones. This is the rewritten test that is made by a community guy, and it's called BART's tests or something. And you can run 3 memory tests on this at startup, and it also notices bank 1 is bad, and it also points to these bits here, I think. So what is actually the case here? Is it the higher bytes, higher bits, or is it the lower ones? And this is a newer version number, so that they should have adapted a new fault. It's not very likely, and it's also stated that this is the lowest ones. And normally when you count to this is the least significant bit, and this is the most significant bit when you count this. So this also points to this situation we have here. How do we identify this in the schematics? Yes, we can look here on these schematics. You have here, this is the original one, and we had the U46 to U49, And this is the ones that we have here. So these are the ones that is marked as bad if you follow the original schematics, and here they all state the 4 circuits. But if you take into account what's happening in the real world up here, you do have another situation. And if you follow the signals on this, you have the CAS 0 and the CAS 1 down here. And the CAS 0 is controlling these ships up here, and this is the lower bank. So this is bank 0, and is working as it should, and it's also fully tested in the C64 modus. Every of these ships is tested in the same way as in the C64, while the 128 does not perform memory test at startup. And you can see here CAS 0 is controlling these 2, but the CAS 1 that is controlling the CAS down here is going up to these 2 ships. So one of these 2 are bad, but which ones? And we can see here that they are connected to D0 to D3 and D4 to D7. So if I'm going to pick, this is our culprit, U40. So this is the one we have to change. And while we are in the mood of mansplaining things, it can get even worse. And if you see here what they have done to this OR gate, they have inverted both the inputs and the outputs of an AND gate. But this is just a schematic drawing technical issue, because it's stated that this is a 7432 chip, and the 7432 chip is a OR gate. So you do have the inputs here, 1 and 2 on this one, and the output on 3. And you have the uppermost here, you have the inputs here and the output here. So they are using this gate and they are using this gate on our circuit here. So this is just another way of putting an OR gate in the schematics, and a bit confusing for most of us. So that means next episode, or until next episode, I have to desolder U40 and put it in a socket, and hopefully then we will be finished with Per Vidar's 128 DCR. But of course we can't be sure until we have run some of the diagnostics again. And by now I have heaps of them. I have 7 of these EPROMs burned, and I can also say that we can test this one again. This locks up when it comes to this error, so it doesn't complete. So this test here we can test the next time too, and see if it's running true when I have changed this. But every one of these should show this as okay when we have finished the next test. But all this confusion down here, it's probably programming errors. Maybe there's new programmers, maybe they have misunderstood the source code. I'm not sure. But at least not everything is right here, that we can see at once. But that's it for this episode. It has been very much mansplaining, it's much diagrams and much other stuff, but I hope you have learned something. Hope to see you in my next video. Until then, take care.